quick, and there's not much, really not, and then you guys can work, and I'll put the little fractal thing up here. So just quickly remind me, and just kind of think about this on your own for a second. What is the product rule for product of u and v, where u and v are just functions of x? What do you got?
U prime plus v u prime.
There it is.
Wow.
Okay. Quotient rule.
So fast.
Quotient right here. Yes, sir.
V u prime minus u prime
Over v squared. There you go. Perfect. Okay, so those are the rules, right? Top one, very simple. It's a sum, so you can get it out of order. Bottom one, you cannot. You have to remember it exactly because it's a difference. And if you mix up the top, if you transpose the top terms, you've got the wrong formula. You get the negative of what you are supposed to get. Opposite you're supposed to get. Okay, so let's derive some other, we've got two trig derivatives at this point. Derivative of sine x is, derivative of cosine x is negative sine x. Okay, but we don't have the other four composite trig functions. So let's look at those. Let's start with tangent, how about? So we're going to do the derivative with respect to x of tangent x. So raise your hand here. Let's see. Does anybody have an idea how I might want to go about finding this derivative? What do you think? What do you think? Jill, what do you think? Any suggestions? You need to raise your hand, but I can tell you were thinking something good.
Yeah, definitely. Well, we can't separate tan and x, can we?
What do you mean?
Because aren't they inseparable?
The tangent and the x?
Yeah.
Yeah, no, tangent of x is just one thing.
Yeah.
But, what can I, you're on to something
It's
here.
like-
Sine x over cosine x.
That's
Yeah.
what I was about to say, Gabriel.
Okay.
We all know it, Jill.
Thanks, Tyler.
Derivative of a quotient, sine x over cosine x, right? Now we have a quotient rule, so now we can deal with this, right? So u is sine x. This just sounds like bad grammar. U is sine x and v is cosine x, right? Okay? So what are we going to get if we use the quotient rule? What do you think, Liz?
You're gonna get cosine x times sine x, or
Times derivative of sine x, which is
which is
cosine x. Okay?
minus sine x times
Minus good sine x times
negative.
negative cosine x, right? Everybody agree? So what do we got so far? We got low d high minus high d low, right? Did I get that right? Low d high minus high d. Oops, I messed that up though. I meant to put minus. I messed that up, didn't I? Should have been minus sine x, not minus cosine x. The derivative of cosine is minus sine x, all divided by what?
Cosine squared. Cosine squared.
So we say cosine squared x, okay? And if I simplify the top, what does that become?
Cosine squared x.
Cosine squared x, then I get minus times minus is,
Plus sine squared x.
okay, so sine squared x plus cosine squared x over cosine squared x.
Cosine squared.
Okay, so does anybody say it again?
Cosine squared is canceled.
No, they don't. I can't do that because this is being, now everybody gets that, right? That'd be like saying this. That'd be like saying 1 plus x over x is 1, but it's not. I can't do that, right? Yes,
So
sir.
could you separate them and then you get like tangent squared x plus 1?
You could. You could get tangent squared x plus 1, okay? You could, and that's okay, but there's something better here. We can make it simpler. Instead of having two terms, and here's my hint. It goes back, and I've started to put together, I haven't gotten all the problems built yet, but somewhere along the line here in the very near future, I'm going to give you guys a memorization sheet of just some trig stuff you got to go through kind of on the side, because this is stuff that I want to pop out at you more than it is. What is that equal to? Sine squared x plus cosine squared x.
One.
It is, it's 1, right? Okay, think about why that is. I'll just do a quick reminder of why that is. Think unit circle. Okay, unit circle, and the unit circle is just like everything is in the unit circle. I'm such a big proponent of really knowing the unit circle well. So if I take a random angle, call it x, what are the coordinates of that point right there?
Cosine of x
So cosine of x,
and sine of x.
in other words, if I make a right triangle out of this, what's the x, where's the horizontal component? Horizontal length, that's cosine. The vertical is sine x, so just think of this picture. The picture says it all. It's a unit circle, so what's the hypotenuse? 1. What's that tell you?
It's squared plus sine squared.
Yeah, right, there it is. Sine squared x plus cosine squared x equals 1 squared, which is 1. All it is Pythagorean identity on a unit circle, right? That's it. Okay, so then if we get 1 on the top, what's this become? So we just end up with 1 over cosine squared x. Well, what's the reciprocal of cosine? Secant. There's your answer. Secant squared x. Okay? So let's add, we've got the derivative of sine x is cosine x. I'm going to add to the fold here the derivative of tangent x with respect to x is secant squared x, right? Okay. Let's try another one. Questions on that?
Can I just copy it?
Oh, sure. I'll come back to this page a whole bunch. You know, I'll take a picture of it at the end, because there's going to be more on this page soon.
So does that make the derivative of cosine?
Okay, we'll get to that. Yeah, we'll get to that, because there's a way to remember those. There's a way to remember it. Just hold that thought. Hold that thought. So let's do, how about we did tangent, let's do secant. The derivative with respect to x of secant x. How would we maybe write that one?
1 over cosine x.
Okay. 1 over cosine x, right? Is that what you told me?
Yeah.
Okay? And this is not the best way to do this. Starting next week, we're going to have a better way to do this problem than the way I'm doing it right now. But we can do it using the quotient rule, right? If it seems a little hokey to do that, you're right, and we'll have a better way to do it, but we just don't have it at this moment.
Can't we just take cosine to the negative 1?
How are you going to do that, though? You guys don't know how to do that. That requires the chain rule, which I haven't taught you yet.
So that's what the easier way.
Right.
So we keep on learning the hard way first.
Well, I mean, it's not that much harder. It's not that much harder. This isn't a big deal. So in this case, if we think of this as a quotient, the quotient rule will work. They're just, you'll see there's a slightly better way you'll know soon.
And also think of it this way, imagine if you taught us the shortcuts first, and then we learned the long way, we'd never want to learn the long way.
Well, in this way, I mean, this is nothing you'll ever do again. I just want to derive the formula, and then you'll practice using the formula. So what's this going to work out to be? Okay, Liz, you're my go-to on the quotient rule. Here we go. Here we go. What do we got?
Cosine x times.
There you go. Cosine x times 0 minus
1 times
divided by,
cosine.
okay, so what's that work out to be? That's 0. This becomes positive, right? So I get sine x over cosine squared x. Can we write that as a product instead of a quotient? Can we split that up in a way?
So next time's 1 over cosine squared x.
So, well, no, we don't want to do that, because 1 over cosine, we don't want to do that. We can do a little, can we break it up? I mean, that would work, but that's not the, so we could break it up into sine over cosine, and right? And then what am I left with? Just a 1 on the top and a cosine on the bottom? Everybody agree? What's 1 over cosine? What's sine over cosine? There you go. So we got another one. So we got another one we can add. Okay, right? Now here's how I want you to think about this. The trig derivatives, you can break them into two columns. There's 6 trig derivatives. We've got what I call the regular trig derivatives. We're taking the derivative of the non-co-trig functions, right? Derivative of sine is cosine. Derivative of tangent is secant squared. Derivative of secant is secant tangent, right? Okay, well, you already know one of the list of the derivatives of the co-functions. What's that one? Yeah, okay, so somebody make a prediction then. If the derivative of cosine x is negative sine x, can somebody predict a pattern here? What do you think the derivative of cotangent x is going to be? Negative,
Secant squared.
no,
Cosecant squared.
that's it. Okay. So what do you think? Can we get, Ryan, make a prediction for me. What's the derivative of cosecant going to be?
Cosecant x times.
Almost.
Cosecant, cotangent.
Cotangent, right? So you look at the pattern here. Do you guys see the pattern? A couple things going on. So when you differentiate the co-equivalents of the regular trig functions, what's the difference? Well, for one thing, you get a negative sign in your answer for all of them, right? And the other thing is, all you're doing is sine becomes cosine, cosine becomes sine, tangent becomes cotangent, secant becomes cosecant. They're the same formulas, only you're just swapping out the co-functions for the regular functions. So they're easy to remember. If you can remember these 3, you get 6 for the price of 3, right? You can remember the 3 regular ones. It's easy to build the co-ones from that. And pretty soon you just remember them all, because you use them so much, right?
There's supposed to be an X.
Did I forget one? Oh, yeah, yep, you're right. That should be an X right there. Did I have some? No, I didn't. I just forgot it.
Nice job, Mr. Williams.
Yeah, so you're gonna see lots of that going on, I'm sure. Okay? Make sense? Okay? Pictures? You want me in that picture?
If you wanna be.
That's okay.
Ooh, I could get a picture for the yearbook right now. Pretend like you're doing something.
Yeah, what do you mean? I am doing something.
Oh, that was a perfect expression.
Okay.
So it's like,
Pretend you're doing something interesting.
oh.
Okay, so let's try this then. So how about a couple practice problems with this? Let's look at something like, why did I pick that one? Oh yeah, there we go. Okay, we'll start easy.
Are these actual problems or are we taking one?
I'm just giving you some practice problems. That's it. Just gonna have you take a couple derivatives. Just using the new rules. That's it. No big deal. All right, what am I getting on this one? Derivative of e to the negative x, or negative e to the x is? Negative e to the x, right? The negative is just a constant, leave that out front. Derivative of e to the x is e to the x. Derivative of tangent x? There you go. How about, okay. How about that one? So, okay, now we need product rule, product rule stuff, right? So we got product of u and v, right? We're going to do a derivative of a product, right? I've got u is x squared, because you just got to think about what are the things that are being multiplied here. I got the function x squared times the function tangent x, okay? So the derivative of u times v is, somebody remind us, what is that, Luke?
So,
Well, I mean, just in terms of u's and v's, what are we going to get? Okay, plus
e prime u.
okay, so u. Okay, yeah, I'm gonna mix the order around. But you're right. U v prime
Where'd it go?
plus v u prime. So Kyla, you're up. Now let's see, so I got u, what's my u? X squared. What's my v prime? Secant squared, good. Alright, plus, what's my v? What's my u prime? So that's it. All we would do is maybe clean it up a little bit. Just put the 2x out in front of the tangent, and that's it. That's all we can do, right?
You had a really messy
I did, meaning
It was fun, but it was,
pretty, on the first assignment?
it was just 2.3.
Okay, let's,
You had to do the, I figured it out, but it was like, you had to do the product quotient and then the
yeah,
other one.
you had a product rule inside the quotient rule. That's a
Big
big
one.
one. Yep, that's a big one. I agree. I agree. That's a tough one.
It was fun though.
Yeah, those are, so everybody get that? If you got a product rule inside the quotient rule, just real quick, I don't want to do the whole thing, but just think what that's going to be like. Like if you have, I'm going to make I don't want to make an algebraic one. I want to make one like with e to the x's it'd be easy, right? So if you had something like f of x equals e to the x times sine x over, let's just say x to the fourth, right? What's my u? The whole top, right? My v is the whole bottom. So every time I take a u prime, I got to use the product rule to do my u prime, right? See what I'm saying? So that's, you got a nested, you have a product rule nested in a quotient rule.
You have a quotient rule nested in a product rule nested in a quotient.
You could, yeah, I don't know if I'd do that to you, but you could.
You could do that out of
All right, so how about,
at least we're going to make sure that we get to it. Oh, I guess I should. It's not total classification. Afterwards on torture.
Unless they're all the same number.
Oh, no, dude, 5.
I won't watch it.
Good job. It's not.
1985.
I was just thinking of
okay, so I want to know, see if you can tell me real quick, what is the, not the first derivative, not the second derivative, not the third derivative, but I want to know what's the fourth derivative of x on that one. You keep thinking about it. I'll just work through these, and that's going to make it a little easier. What's the first derivative going to be? I'm going to get
12x to 2 minus 4x plus 10.
second derivative.
80x 36x squared minus 4.
Third derivative.
240x squared. See that? 72. 2x.
Fourth derivative.
480x plus 72.
What's the ninth derivative going to be?
0.
Right? I'm going to get to 0. The fifth derivative is 480. The sixth derivative is 0. And then from then on out, 0. Right? Okay?
So are we going to have an instance solely dedicated to like taking the 100th derivative?
No. No.
Could we replace one of our assignments with that assignment?
No. That's just a lot of sense. You can do that. That's right. Just make up one for yourself. But that's a lot of work for very little payback.
You just say, okay, well, we're doing
Okay, let's calculate this is a good one. Let's just do more like this. Okay, let's take a second derivative. Take a second derivative of secant x. So what's the first derivative?
negative cosecant squared.
No,
Secant, tan.
secant tangent.
And then you have to do the product rule.
Exactly. Okay, so if we're going to take a second derivative, so what are we going to get there?
Oh.
Product rule, right? So I'm going to do secant
Squared.
x times, what's the derivative of tangent?
Secant squared. So we're gonna get secant to the third.
Good. Plus tangent x times
Secant tangent.
derivative of secant x is secant x tangent x, right? Okay, now if we wanted to go further with this, I just want to illustrate, 'cause I think this one will be one that'll work. I think it'll work. So if you wanted to go further with this, here's why it's valuable to know your trig. Actually, it's not going to work anyway. Never mind. Secant squared plus tan squared. Okay, so I want to show you something real quick, because this is real. I was going to show this to you later, but I'll show it to you today. So we already know the Pythagorean trig identity, right? Sine squared x plus cosine squared x equals 1. Okay. This is how I always do this for myself. I never remember these because I don't want to waste the brain cells remembering something. I can just think about how to derive it really quickly. If I want to come up with the other two Pythagorean trig identities, all I've got to do is divide both sides by sine squared or divide both sides by cosine squared. If I divide both sides by cosine squared, what am I going to get? Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is
Secant squared.
secant squared. If I divide both sides by sine squared, I'm going to get 1 plus cotangent squared equals cosecant squared, right? And so in this case, if I wanted to rewrite this thing in a way that maybe was a little bit easier, I could do something like, I could take this tangent squared right here, right? I could write this as secant cubed x plus secant x times tangent squared x, and what's tangent squared x equal to?
Secant squared x minus 1.
Secant squared x minus 1. Right, so look what that does then. I could write this as secant x times secant squared x minus 1, and I end up with my second derivative equaling powers of secant. I'm going to get secant cubed x plus, if I distribute, secant cubed x minus secant x, right? Well, that just gives me, my second derivative is 2 secant cubed x minus secant x. So now I've got it written as a function of only one trig function, right? Which makes things a little bit easier if I wanted to work with that second derivative, right? If I wanted to differentiate again, we're kind of stuck now because we don't know how to deal with that yet. That requires something that.
Over and over.
Well, you'd have, and even then, we can't really, you guys don't know how to deal with that yet. You don't know how to deal with the derivative of
2 times secant
composition
x
of
times
functions.
secant x.
Secant x inside a cubic function, right? So that's the secant, see what I'm saying? It's the quantity secant x cubed. So you got two layers there. You've got a secant x, but on the outside you've got something z cubed. That's for next week, but schedules. All right, I don't have any. I got one of these for you though. I gotta go get some. There you go. Uh-huh. Okay, and I think that's probably a good place to stop, I think. Yeah. All right, how much time we got?
3 minutes.
3 minutes. All right, well, at least you can watch my little Mandelbrot video for a little while.